Hey everybody, this is Miss Eisencraft, and I am here to do a lesson recap of Unit 4 from this book, Algebra 1, Units 3 through 5, Unit 4, Lesson 1. So Unit 4 is all about functions, which you began covering in 8th grade pretty extensively, and we're just circling back and then going a little bit further with it. So it starts off by really making sure you understand the definition of something being a function with this little bagel problem. And here's the definition of something being a function. Each input can only have one output. So when you're talking about something being a function, you have a relationship of two variables. And we call one the input, one the output. And in order for it to be identified as a function, every input can only have one output. And they illustrate this bagel problem by saying, okay, here's some prices of the bagels at this store. And they're saying, well, we want to buy 13. And because of the way the pricing works, because it's kind of like jumbled all over here, it's not following a real distinct pattern, people are coming up with different prices. The shopkeeper says, it's going to be $16.25. I think he's getting it by calculating 13 times $1.25. And then somebody else says, wait a second, I think it should be $13.25. So she's getting it by getting 13, the price for 13 bagels, doing a different combination. I don't remember if she's doing like 2 groups of 6 bagels. Yes, 2 groups of 6 would be $12 and then one more. And then another person even says, I think it should be $11.25. They're all correct, and you can get that price from all of them, right? $11.25 would be from getting 12 bagels for $10 and then just adding one more. So because this input has multiple different outputs, this relationship of bagels to price would not be considered a function because this input, this 13 bagels, has a bunch of different prices. And on a graph, you can usually tell quickly that something's not a function because the input, which is along the x-axis, has multiple different outputs on the same vertical line. And that's how you can tell something's not a function. All right. The next thing is asking, like, can you sort of illustrate from words into a graph how the variables relate with one another? So they give an example here about tying your poor dog up while you run into the store and then giving you some information. And when you're graphing a function, this is a function because at every specific time, the dog can only be one distance, a certain amount of feet from the post. You can't say at 40 seconds the dog is a foot away and 3 feet away. As time is going forward, there is only one possible distance the dog could be. Now the dog could be going like kind of pacing, going away from the pole, closer to the pole, away. It's limited by 6 feet, but it could keep just kind of going crazy until the owner comes back. But notice there's no part of the graph on top of itself because at every time there's only one distance the dog could be. So here in this one, we're not going to go too far into it. They give you 2 exact points in time that you do know the dog's exact distance, but they're just kind of asking you to think to match a story with as time going forward, how far is the dog from the post? And they give you a different scenario. I think the second one says the dog walks around and then he lays down. So he walks around. It tells us we know for sure at 60 seconds this is where the dog is. But then after a minute, he lays down. So then his distance stays the same. So kind of interpreting what these flat lines would mean in this relationship, right? What would the up and down mean when you're looking at these 2 variables? Okay. So graphing these, and we do that in 8th grade a lot, not everything is linear. We do a lot of things in math that are linear, but there's lots of things that aren't linear, lots of functions that aren't linear, and we're just going to talk about how the 2 variables work with one another. And then lastly, we're going to define this idea of independent. Where's my papers? Independent versus dependent variables. I'm just going to write it. Okay. So when you have an independent versus a dependent variable, you have two variables and you're asking how they work with each other. And you want to think of one, we often think of the independent as the input and the dependent as the output. Okay. In science, I think they can call sometimes this one the manipulated, this is the responding, but usually this is being calculated as a result of this. The dependent depends on the independent. And what we say, we're going to come up with this new statement now when we're talking about functions. The dependent variable is a function of, so this is the new terminology for you guys, is a function of. And you can almost think, you can replace that if that confuses you for a while. Depends on is a function of the independent variable. So oftentimes time will be the independent variable. You're maybe measuring something as time goes on. I think in the example here, they give you like time in minutes, you're preheating your oven, and then like the temperature, maybe in degrees Fahrenheit. Okay. So you could say the temperature of my oven is a function of time, right? It depends on how long you've been heating up the oven. So sometimes you can like maybe get creative and flip it around, but oftentimes if you flip it around, it's not a function. They give an example of like the height of an airplane. The height of an airplane, so it's altitude and time. And if you make time your input and the height the output, and say, well, the height of the airplane is a function of, how long it's been in the air. So the height of the airplane is a function of time. This would be a function because every time would have one height. You can't have a time of like 1 minute and say, at 1 minute, the plane is here and here. There's only one possible height at 1 minute. But if you flip it around and try to say height is the input and time is the output, there maybe the airplane is at like 1,000 feet at two different times, one on its way up, one on its way down. So all of a sudden it's not a function. So we start to kind of interplay with that dependent and independent. But for now, if you really think of independent being the input, dependent being the output, and then working with this phrase, the dependent variable, usually the y, right? The y, the output, the y is a function of, depends on x. That will help you out, and it'll start to make more sense when we start to use more function vocabulary as the units go on and as you take more math the following years. All right, good luck.